Hi there, Cuba Libre and all the rest of you good people out there. I hope that you're all safe and sound and that health is with you. Regarding your question on the forum on using the sheet metal application to build a bracket, this following is what I would do. Now, I assume that given the geometry you have there, you have some reference geometry where you want to attach a bracket to that is going to fixate, let's say, this pipe here. You want that in a certain direction, so it's going to be following the coordinate system given here. So it will be a square around that. Now, in order to start this off, we need some curves, and we need the vertical center curve of that pipe there. With that given, we can now create a contour flange. We're going to create a base flange, and we're going to base that on that center curve there. So we're going to use that as a path curve. And yeah, well, let's put it there. That will be fine. So our bracket will be up here, actually. I'm going to build it oversized. We're happy with that. So we need some reference geometry here. And I'm going to use intersection curve on that pipe. And I'm going to use intersection curve on the top face there, which the bracket is going to attach to. And we say OK to that. I'm going to use a line to connect these two. It's going to be a vertical line, so lock it vertically and then reach to that line there, or the intersection line. Same here, we lock it vertically and to that line there. I'm going to trim some entities away. We're going to lose the associativity. We do the same here. And if you lose them, it's not the end of the world. We see that obviously I trimmed a little bit too much off there, so I need a line there still and down to that there. There we go. We recreate that intersection curve there, and we create yet another one here, and we say cancel to that. These guys are going to be reference geometries. You can see that the sketch is fully defined there as well. So with these prerequisites here and the prerequisites of hard corners being blended in our flange, we can see that this is what we will get. Okay, so it's going to be a rather thick one, but that's fine. It's going to be 6 millimeters here. That's okay, that's fine. We're just showing the principle here. So it's going to hold this pipe here with some rather massive flange, but that's fine. So we say OK to that, and we're happy with that. Next thing is to create our cutout. And the cutout here, I'm going to put it as a sketch on the datum plane, not the path, on the datum plane of my sketch there, which I said, or the datum plane, or I already had the datum coordinate system there. We're going to create a rectangle here. It's going to be no exact science here. Oops, no exact science. We're going to put it, let's say, roughly there. And then we're going to finish that, and we're going to say, so it's cutting something away that I don't want. I want the other side, so I flip that around. It's also cutting the wrong body. We don't want that. We want the flange body that we created. We can also see that the cuts are going to be normal here. And we do accept that with an OK. So that means we have formed our flange here. That given, we need to unbend it, so we can unbend it. You can do that by selecting one face, and you can select all the related faces to that in order to make that kind of a flat pattern, and you can return back in time and flip between formed and unformed. So I hope that helps in your future endeavors, and that's all from Fred for now. I hope this helps in your future endeavors. So over and out from Fred. Take care. Stay safe, and above all, stay healthy. Bye for now.